Sporting ammunition and the firefighter is produced by SAMI, the Sporting Arms and Ammunition Manufacturers Institute. SAMI was created in 1926 at the request of the United States federal government to create standards related to safety and reliability in firearms, ammunition, and components. This video is part of our continuing mission to promote safety, in this case by providing firefighters with fact-based information to help them address the realities of fires that contain sporting ammunition.
Each year around the world, the public shoots billions of cartridges and shot shells. Rifle and handgun cartridges consist of a brass case with primer, powder, and bullet. Shot shells are similar, but also have a wad that holds the shot. Sporting ammunition includes shot shells up to 8 gauge and handgun and rifle cartridges up to 50 caliber. This video examines sporting ammunition only. It does not address military or law enforcement ammunition such as tear gas cartridges, tracers, or incendiary projectiles. Warning: these demonstrations do not apply to a loaded firearm. In a fire, a chambered firearm will shoot as if the trigger was pulled. SAMI thanks the International Association of Fire Chiefs for their input during the making of this video.
Being a firefighter, we always encounter risks and hazards. And before we enter into any incident, we should be doing a risk assessment and looking at the levels of risk that are involved. I think in the following demonstrations with small arms ammunition, you'll also realize that the risk is very low and should be treated no differently than any other hazards in structure fires.
Smokeless powders must be confined to propel a projectile at high velocity. When not in a firearm, projectile velocities are extremely low. To demonstrate this fact, a special test device was made to hold cartridges one at a time for igniting and filming in slow motion. The 12-gauge shot shell is the most common shot shell available. Without the confinement of a firearm chamber, the shot does not penetrate standard 200-pound fiberboard at a distance of 7 inches. The projectiles superficially mark the fiberboard. Much of the powder is left unburned. An unsupported 500 Smith & Wesson Magnum handgun cartridge exhibits more energy than a shot shell. The brass breaks apart and the bullet may penetrate one sheet of 5/8-inch sheetrock. However, it may not even penetrate that far, which happened here. The .416 Remington Magnum rifle cartridge is one of the largest sporting cartridges, but acts similarly to the Magnum handgun cartridge. Conclusion: projectiles ignited outside a firearm have significantly lower velocities and energies than when shot from a firearm. If ammunition is dropped in transportation or storage, will it ignite? To answer this question, consumer packages of ammunition were dropped from a height of 65 feet, measured with a length of rope. The sporting ammunition consisted of a 50-round box of Federal 357 SIG handgun cartridges, a 25-round box of Remington 12-gauge shot shells, and a 20-round box of Hornady 458 rifle cartridges, one of the biggest cartridges on the market. Consumer packages of shot shells, handgun, and rifle cartridges were dropped at the same time. From this extreme height, 2 of the handgun cartridges ignited. There was no propagation from cartridge to cartridge. Next, 3 shipping cases of the same ammunition were dropped from 65 feet. These cases contained 200 rounds of rifle cartridges, 250 rounds of shot shells, and 1,000 rounds of handgun cartridges. None of the ammunition ignited. Conclusion: when dropped from extreme heights, sporting ammunition is unlikely to ignite. If a cartridge ignites, it does not propagate. If a cartridge is ignited accidentally, will it ignite other cartridges? The ultimate test is to shoot boxes of ammunition with a high-power rifle. Ammunition in retail packaging and shipping cases was placed on a pedestal in a cabinet to help contain the impacted cartridges, which can scatter for 20 to 30 feet. The cabinet also protects the slow-motion camera. Some unignited cartridges were not found immediately, but all cartridges were accounted for by the end of the day. The .308 caliber rifle used here is shooting 150 grain bullets at 2,610 feet per second from a distance of 65 yards. Handgun, rifle, and shot shells were tested. A retail box of each type was shot, followed by shooting a case of the same ammunition. Four cartridges ignited. Five cartridges ignited. Gunpowder poured out of the impacted cartridges. Three cartridges were ruptured without igniting. Five cartridges were damaged. Three of them were ignited. Gunpowder erupted from the shot shells without igniting. Four shot shells were damaged. One primer was destroyed, which did not ignite the shot shell. Conclusion: most of the ammunition did not ignite. When a cartridge did ignite, there was no chain reaction. Blasting caps are used to ignite high explosives. They send out a shock wave and fine aluminum fragments. A blasting cap was placed inside a box of .458 Winchester Magnum rifle cartridges. The blasting cap destroyed the package. None of the cartridges ignited.
What we just proved is that you can totally destroy the package and not ignite the cartridge.
It was decided to place a blasting cap outside the package. A box of 50 Winchester .45 Colt cartridges was used. A primer was exposed. The blasting cap was affixed on top of the exposed primer. The targeted cartridge ignited, but no other rounds ignited. There was no propagation. The 50-round box was largely undisturbed. Next, an entire 250-round case of Federal 12-gauge shot shells was used. Holes were cut through the fiberboard and consumer packaging to expose a primer. The blasting cap was attached directly against the exposed primer. The targeted shot shell ignited. There was no propagation. The 250-round case was largely undisturbed. The test showed that blasting caps are usually unable to ignite sporting ammunition. When placed directly against an exposed primer, the blasting cap may ignite that cartridge. There was no propagation from cartridge to cartridge. Conclusion: ignition using a blasting cap is difficult and does not propagate. A forklift was driven at high speed into a pallet of ammunition. There was no ignition. Damage to the ammunition was negligible. To show a worst-case scenario, it was decided to place the ammunition on asphalt and crush it with a bulldozer. 3 shipping cases of ammunition were laid out. These included 200 rounds of Federal 7mm Remington Magnum rifle cartridges, 200 rounds of Hornady 44 Magnum handgun cartridges, and 250 rounds of Federal 12-gauge Magnum shot shells. The bulldozer crushed the cases. No ammunition was ignited. Since crushing the ammunition did not cause the sporting ammunition to ignite, it was decided to conduct an extreme test. All the packaging was removed. The ammunition was left in piles on the ground. The bulldozer then ground the ammunition on the asphalt. This demonstration is extreme, but it shows ammunition's resistance to accidental ignition. During 30 seconds of grinding, 3 shot shell primers were ignited. Many primers were crushed without igniting. Two rifle primers were ignited. No propagation occurred. Many cartridges were crushed without igniting. None of the handgun cartridges ignited. Conclusion: even in the most extreme conditions of compression and friction, sporting ammunition is unlikely to ignite and does not propagate. A bonfire of packaged ammunition was conducted. The purpose was to measure the danger of projectiles from an ammunition fire and to demonstrate that sporting ammunition does not mass explode in a fire. 28,000 rounds of sporting ammunition were placed on a mesh table above a wood and diesel bonfire. 9 witness stands were placed around the fire, 15 to 50 feet from the bonfire. The witness stands each consisted of a 2x4 wood rectangle. This stud wall frame was covered front and back by 2 4x8-foot sheets of 5/8 inch sheetrock. Diesel fuel was applied to the wood and paper fuel. The bonfire was ignited. The ammunition began to ignite. The ammunition was now fully involved. Melted plastic from shot shells burned on the ground.
The witness plates that we set up made of sheetrock were at various distances from the fire to show exactly how much hit them and with what force it struck. Only a few pieces of the ammunition actually went through the first piece of sheetrock and none penetrated the second. A lot of the pieces of ammunition stuck into the sheetrock and can still be seen protruding from it. We stepped out from behind the shelter that was used for the video cameras in our full firefighter turnout with our face shields down on our helmet, and were able to feel some of the pieces of the ammunition striking our turnout gear and falling to the ground. Nothing with enough force to actually tear into the turnout gear or injure anyone.
Ammunition in a fire can be intimidating. The noise is intense. You can see and hear projectiles flying past you. This test demonstrated that sporting ammunition in a large and intense fire does not create projectiles dangerous to firefighters within a reasonable working distance. Conclusion: sporting ammunition fires are noisy, but the projectiles have low energy and are largely confined by sheetrock at short distances. Normal turnout gear will protect the firefighter at a reasonable working distance. $18,000 rounds of sporting ammunition were placed in a mesh box without any packaging. The bonfire was doused with diesel and ignited. The absence of packaging did not increase the intensity of the fire. Heat and weight caused the stand to collapse. The ammunition burned at a consistent rate for 7 minutes until the fire was removed. The plastic from the shot shells kept the fire burning after the wood and diesel fire was removed. Conclusion: the lack of packaging did not cause the ammunition to burn more fiercely. No explosion occurred. $115,000 rounds of sporting ammunition were placed in a simulated retail store. This included shot shell, handgun, and rifle ammunition. There was a large amount of ammunition in a small area. The wood and diesel fire was intense. These factors created an unusually intense ammunition fire. The fire was ignited.
Now we're going to make an approach with two different attack lines, kind of an off angle to the door. We just completed the firefight on the retail store of over 100,000 rounds of ammunition. We came up with two different hoses, and the initial officer to put his wide pattern fog line was almost immediately effective. Dave and I came around behind him with that narrower fog and reached the back of the building, and we were very effective. It worked extremely fast.
As we were approaching the fire, there really wasn't any projectile threat. Anything that came out the door was very low velocity, and nobody got struck as we were making our fire attack by any projectiles from the fire.
The wall in this room was a normal stud wall made out of 2x4s. The front of the wall was covered by 5/8-inch sheetrock. The back side of the wall consisted of 7/16-inch wood wafer board. The sheetrock was tested more severely in this test than in the Bonfire. The sheetrock in this scenario is only 0 to 5 feet from the ammunition. None of the 115,000 rounds was more than 12 feet away from the sheetrock. There were many penetrations of the sheetrock. The sheetrock penetrations are best seen by the sheetrock dust on the wood sheeting behind. No evidence of any penetration or even any dent was found on the wood sheeting. At one place in the wall, there were 2 pieces of sheetrock overlapping. The second piece was undamaged. Conclusion: the fire was controlled within 10 seconds. Projectiles were low velocity and did not impede the firefighters. Five pallets of sporting ammunition containing 252,000 rounds were placed in a semi-trailer. Wood and paper fuel was piled against the pallets. The fuel and pallets were soaked with 10 gallons of diesel fuel. The fire was ignited. A firefighter stood in the path of the projectiles and was struck several times with no adverse effects.
We just finished extinguishing the semi-trailer fire. We were able to get up here and knock the fire down very quickly with the 2 attack lines. We had to climb up into the trailer and get at some of the hidden hot spots that were back behind the pallets of ammunition. And we were able to do so while the ammunition was still going off.
I walked up to the fire after it was in full blaze and the ammunition was going off very quickly. And I'd seen that it didn't penetrate sheetrock in previous tests, so I came up and tested out my turnout gear at close range. And I felt being hit many times, but there was no pain sensation or didn't feel very hard.
From my vantage point, I was pumping the structure truck, supplying the water for the fire suppression. From what I saw, I mean, the noise is just enormous of the rounds going off. I had no exposure to any of the live rounds. Everything was coming out the burnt portions of the trailer, the loading door. Everything from my vantage point was relatively safe.
Conclusion: the fire was controlled within 10 seconds. Projectiles were low velocity and struck but did not impede the firefighters. Over 400,000 rounds of ammunition were used during the demonstrations shown in this video. These demonstrations confirm that sporting ammunition is difficult to ignite. Ammunition does not propagate, burn, or explode when subjected to extreme stimuli. When subjected to fire, ammunition is loud and launches small debris. However, these projectiles do not injure firefighters or inhibit them from proceeding with their duties in the immediate vicinity of a fire. Firefighters may safely and quickly extinguish burning ammunition with standard methods using water. Firefighting personnel must wear standard fire protective gear, including self-contained breathing apparatus, and keep it on while extinguishing hot spots after the fire is controlled. Sporting ammunition does not pose a fire or accident hazard substantially different from other common commodities, and in fact is less of a risk than many household products.